Okay, welcome back, everybody. This is the Basics V3 Intro to Electronics. It is electronics class. We're using e-tron Circuit Labs, and this is our Lab 4 class. So we're going to be on page 16 and 17 in our book. Please note, if you're interested in this material, it will be listed in the description box below. Okay, so we're going to be learning about capacitor values and types of capacitors today. At this time, I would like for you to grab your parts box, set it on top of your lid. If you're purchasing it, it may look like a parts bag, and then you'll have all the supplies in there. You can go to etroncircuit.com to purchase this kit and book. Okay, inside your parts box, open it up, and I want you to pull out all your capacitors. Every capacitor you have. If you do not know what a capacitor looks like, you've got homework to do on page 8 and page 9. It tells what all of the labs all the components are in our parts box. Sorry about that. Okay, let's jump right into it. A capacitor would be one of these right here, and there's two types of capacitors. Tell me what this one would be. If you said electrolytic, you are correct. You're correct. This is an electrolytic capacitor. Notice at the top of this capacitor, it has what? It has a long wire lead and a short one. Tell me what that means. It means it has polarity. Which one is my positive side? The longer one. If you said the longer one, that is correct. Remain plus. The plus sign means you have more of something. The negative sign, a minus sign, means you have less of something. So they made it just accordingly. It's very common sense. Plus, positive. And then this one's smaller, so it's going to be less, so it's going to be the negative side. If we have a positive and negative, it means it has polarity. So this electrolytic capacitor has polarity. It has positive and negative to it. All right, so that's one of our capacitors. But there should be approximately 9 in your storage container. So let's continue to pull out these capacitors until we get all of our capacitors out, and that's what you should have on your lid. Why do we use these lids? It helps us to not lose our parts. It has a little lip on it, so if we do all our work inside this, it'll keep all our parts together. All right, so your other capacitors look a little different. They're a lot smaller than those. So if you're having trouble with remembering the electrolytic capacitors, once you have all 9 of those out, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can slide your parts box out of the way, and we'll just take a look at these. So these are the ceramic capacitors, and if you'll notice, it's kind of a little bit hard to see, but you can see the second one right here says 103. The one up top says 104. We're going to learn about that value and how to calculate that value in just a moment. On these electrolytic capacitors, they're bigger, so they can house more numbers and letters on the outside of them, so they're able to tell you the size on them, on these electrolytic ones. And just a quick little note how I think of this. I'm going to show you the word electrolytic. It is right here, electrolytic type. 2 types of capacitors. When I think about this, there's a disc type capacitor and the electrolytic style capacitor. We also call that also the ceramic capacitor. But that electrolytic, I think about it, these are electrolytic. I think about how that looks like it could hold fluid. It doesn't mean it holds fluid. I'm just saying it looks like it could. So remember, it could hold liquid. It doesn't hold liquid, but I'm a very visual learner. So when I see that and I think, oh, it kind of looks like a glass, and I think about that, it helps me remember I'm learning electronics. So electro and then liquid, lytic. It's not spelled like liquid, But anyway, that just kind of helps me remember that because that's a pretty good size word, and I'll point back to that. It's on page 16, electrolytic. Okay, that's electrolytic top capacitor. Okay, moving on. A capacitor is used in a circuit to store and discharge electrical energy. So this right here stores what it needs, but it will also discharge the electricity as it's needed. Okay. The larger the capacitor, the larger it can store, the more it can store. We already went over that they have polarity, and polarity simply means positive and negative. So I'm going to pull this over to our picture in our book on page 16. Positive and negative. Here's our capacitors that we have out on our tray. It's the same thing. See how it has positive and negative, and that just lets us know that it has polarity. All right, these little ceramic ones, however, do not have polarity. See how they're all the same length? Their little edges are the same, so they do not have polarity on them. Okay. All right, so we're going to jump right into it. I'm going to be teaching you about capacitance. And the amount of electrical energy stored and discharged by a capacitor is known as capacitance. And that's what our value is. It's like how much that has. When we work with capacitors values, we're going to learn about what they're measured in, just like we did resistors and they're measured in ohms. Well, the capacitance, I'm going to write this out for you. The capacitance is measured in farad. All right, so then we have two units. We have what's known as microfarad, and farad is a very large unit. All right, which is equal to, we'll say 1 microfarad, which is equal to 0.12345 all right, 1 farad. So when I am writing this out, these are just so that you can see what a farad is and how large it would be, and then what a microfarad would look like. Okay, then we also have the term what's called picofarad. So it's PICO and then farad. And then it would be 1 picofarad equal to, and then I want you to watch how many zeros there is. There's 6 zeros, 7, 8, 9 zeros, 10, 11, 12 zeros, and then our 1. And then we say farad, and I'm sorry, I forgot to put picofarad. Okay, oh, no, just farad. I had it right. Okay, just farad. So, now, should I have put the spaces between it? No, I should have just wrote that all together. So I'm going to do that right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1 farad. So it should look like that. I should not have put the spaces. Sometimes I just do that to make sure I get enough. All right, so this is the capacitance of a capacitor, and it's measured in farads, and farads are large units. Well, these little bitty capacitors are small, so they didn't want to have to put big, huge writing across it. We'd have to write tiny, and nobody could read it, so little. So they came up with abbreviations of microfarad and picofarad. And because of that, look how small the number becomes when you add picofarad behind it, and then when you add the microfarad behind it. So it helps the numbers to be small. So if we come back over here and look on our little capacitors, do you see how they can write the 100 microfarad on there? 1000 microfarad. Farad. And then on this one is 10,000? No, 100,000. 1, 2, 3, 100,000 microfarad. Okay. All right. Let's see here. There are 3 characteristics of capacitors. We learned about the 3 characteristics of the resistors in one of our future labs. I believe it was lab 2. But in this one, we have 3 characteristics. 3 characteristics of capacitors. Okay, and those 3 characteristics are, number 1, it has a capacitance. And that is simply measured in microfarads or picofarads. That's what we measure it in. If you remember back in resistors, we measured it in ohms. Well, in capacitors, we measure it in farads. Okay, and we just learned about that. All right. The second characteristic is voltage. In the resistors, we measured them in wattage, but in capacitors, we measure them in voltage. Okay. I would like for y'all to look up on your time a video on voltage, so that you can see exactly what it is, okay, and have that in your mind. What is voltage? What exactly does it mean? Okay, a good science video on voltage. All right, tolerance. We learned about this as well. Plus or minus a percent. It is measured in percentage, just like in a resistor, but in capacitors, it's a plus or minus 20%. Okay, which means 100. Put an example here. 100 microfarad measures as low as 80 microfarads and as high as 120 microfarads, with our accuracy of hoping for 100 microfarads. So this is what it says it is. Matter of fact, we can pull this over here. This is what the capacitor says it is. But when we look at our tolerance, over on our 3rd characteristics of our tolerance, now it could be as low as 80, or it could be as high as 120. Okay. It also tells you the voltage on there. So let me see if I can get that to zoom in. There we go, the voltage. And that's our 2nd characteristic right there. Okay. Alrighty. All right, the 3 characteristics, we've already went over those. So let's take a look at a capacitor. All right, let me zoom out real quick and let you see that information. You can also pause this video right here, and then you can write down anything you needed to or look at it. You could go back and look at it as well. Okay, so I'm going to draw a line right here in my notes, and we're going to look at our first capacitor. So I'm going to draw, and let's go over here to our, and remember we looked at our ceramic capacitors? Right here we had one at 103, and then up here we have one at 104. So I could simply bring this capacitor over to my paper at 104, or I may just do my little, slide this over, put me a little circle here, put me some sticks on the end of it, or my wire leads, and then I may just write 104 on the inside. And that's how pretty much I'll do them as we go along. I'm going to set this back over here on my little table. Okay, so we have 104. I want to show you how to calculate the, there it is, capacitor values. And that's what these are. These are going to be our capacitor values. So I'll write that up here. Capacitor values. And I'm showing you how to work these. Okay. So very similar to our resistors, we simply can take this number 104 and rewrite it. I'm going to underline the first two because that's my base number, or I could also call it my root. And I like to be consistent because it just makes it, so I'm going to write root underneath it. If you like the word base, you can go with base, but we used root for our resistor, so I'm just going to stay with root. So this is my root number. It means it's just going to come right down into my answer. And that's my first answer. Then this 4, my leftover number, is my multiplier number. Just like, I'm going to write that up there, multiplier. Just like in our resistors, I have in a capacitor, I have a multiplier number. So this 4 simply means how many zeros. How many zeros I'll have. So I'm going to add 4. 1, 2, 3, 4. So now I've represented this number as my root and brought it down. And then I'm taking this multiplier where I put my x over the third number, and I'm bringing it over here and I'm saying, oh, that just means how many zeros I have. So I simply write out how many zeros that number tells me. Now I can take all this information and put it into my first answer, which will be picofarads, because that's the unit of measurement. Remember we went over that earlier? The unit of measurement was in farads, and then we come down here and we have microfarads and picofarads. Well, my first answer is going to give me my picofarads. So I'm going to simply transfer all my numbers down here, and then I'm going to add my root because my root stays the same, and I brought down 4 zeros, 1, 2, 3, 4, and then I brought down my 10. Now I can simply go 1, 2, 3, add my comma in. I have 100,000 picofarads. Okay. Now I want to show you something in your book on page 17 at the top. It makes it real easy. If you want to convert picofarads to microfarads, move the decimal point 6 places to the left. Let's read that one more time. If you want to convert picofarads to microfarads, remember micro means small, little bitty tiny, like a microscope, we have to use that to look at stuff. Microfarads, so if we're converting from picofarads to microfarads, move the decimal point 6 places to the left. Let's do that at this time. Remember, that's at the top of page 17. At the top of page 17 is where I've got that if I want to convert picofarads to microfarads. Okay, so here we go. I now am going to say I have this same number, 1, 2, 3, 1, 2, 3, but I want to convert it to my next answer of microfarad. So in order to convert from picofarad to microfarad, I'm going to put my decimal here, and I'm moving to the left. I have to go towards the left, and I have to do it 6 times. 1, 2, 3, 4, 5, 6. And then I put my new decimal there. Okay? So it moved from here, and each one of those smiley faces represents where my decimal is now. So my new answer is 0.1. I don't need all of these because they just hold a place value. And any zero past the decimal can just fall off. It's not needed. So my answer becomes 0.1 microfarads. All right, let's take a look at another one. All right, so in this, let's just make up as another, oops, sorry about that, I wasn't holding it up there far enough. So let's do 547. 547. So that's what I have. We're going to work this one together, and then I'll let you work the next one by yourself. So I'm just going to bring this number down, 547, and I'm going to underline my root. So I'm going to write root there. And then this is my multiplier, so I'm going to put my x above it. So I bring down my root, 54. This is my root. Then I'm going to bring down what? Do I bring down the 7? Just write the 7? No. I'm going to bring down, what is this equal? Number of zeros. And for you that don't know, that's a cursive Z. I can write it above it, zeros. Okay, so I'm bringing down my zeros. And how many zeros do I have? I have 7. 1, 2, 3, 4, 5, 6. I'm going to add that first one here so I can put my commas. All right. Now, when I go to write my picofarad, I like to do it like this because it's neater that way. I'm not separating and my teacher knows my answer. So I'm going to just simply start counting. 1, 2, 3, 4, 5, 6, 7. That got rid of these, right? 1, 2, 3, 4, 5, 6, 7. Now I just simply bring down my root. 54. Okay? That's my answer for picofarads. That's a big O number. 540 million picofarads. All right. Now, if I want to reduce this as to not mess with my teacher, I can do this. Start here with my decimal, or I can rewrite this and actually work it out. Okay, so whatever works best for you. 1, 2, 3, 4, 5, 6. So I do not need these zeros. I just need that answer. So I'm going to write 540, and then I'm going to put my microfarad on there. Okay. All right, let me give you one to work. Let's try this one. And I want you to pause the video right here. 124. I'm going to put it on there. Remember what you're doing first. You're going to have your, write out your problem in 1, 2. Then you're going to come down and you're going to have your next unit. And then you're going to come down and you're going to have your next unit. Pause the video right now. Work this problem. I'm going to continue to work it, and then you can look at it, but do pause it at this time. Okay, so we're going to take our root. We're going to put 4 zeros here because the 4 represent, well, 124, I guess is what we should have did. The 4 represents the number of zeros. Okay, and then we're going to simply bring down our answer. 1, 2, 3, 4, 1, 2, 3, comma, and this is going to be in picofarads. All right, and then we're going to simply remember that we have to go 6 places to the left. So 1, 2, 3, 4, 5, 6. So it's going to be 0.12. Remember, any zero behind there is just there, but it doesn't mean anything. Any zero in front of the decimal, not this in front, but in front of the number, behind the decimal, but in front of the number, does matter, and you would need to represent it accordingly. So that we label it microfarad, and it's 0.12 microfarad. Okay, so I'll leave it on that for just a second. That's how you determine the value of a capacitor. Okay, please do read over page 16 and page 17 for lesson 4. You can go back and watch this video on how to work the problems and find the value of the capacitor. And then you should be ready for class. Thank you for watching.